Explorer sending back unnerving information to Earth. The Explorer 1, NASA's farthest voyaged space apparatus, is as yet voyaging across unseen districts of the universe almost 50 years after its send-off. Researchers are confounded by the startling information that this well-known space test machine is sending back to Earth due to what gives off an impression of being a breakdown. Go along with us as we discuss the odd information that the Explorer has been sending back to Earth during its irritated space investigation. Researchers have been intrigued in becoming familiar with the domains beyond since the Big Bang, and that is what motivated the send-off of the Explorer 1 and Explorer 2, among other space missions. The Explorer 2 was actually the first space apparatus to launch, leaving from the NASA Kennedy Space Center on August 21, 1977. On September 5th of that very year, Explorer 1 was sent off about 14 days later. Anyway, how could they switch places as twins? The weight of the two tests is 720 kilos, which was roughly equivalent to a small vehicle. Both of them were sent off during a window of extraordinary out-of-planet arrangements that caused a slingshot impact to send the rockets from one planet to another. They have, however, had to move at different velocities and in different directions, and on December 15, 1977, the Explorer 1 had the option to pass its indistinguishable twin. Since then, it has been our go-to asset for finding out about different realities in space and related puzzles. The primary space apparatus to do so was this one when it began its Jovian imaging mission in 1978. It was around 265 million kilometers from our planet and sent an enormous number of photos back to us. The Explorer 1 completed an exceptional 100-hour stretch starting in January 1979, during which it captured 3,750 pictures of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's turns. It had gone through the Jovian moon system in February 1979, and after a month it had detected the small ring surrounding Jupiter. Explorer 1 also made a remarkable discovery when it found two new moons named Hoodlums and M. Remedial moves would be made to ensure that the rocket is prepared for its flyby of Saturn and to prevent a possible impact with Titan, one of Saturn's moons. Explorer 1 also found 4 other moons during its orbit of Saturn, including Mimas, Enceladus, Tethys, and Dione. Our researchers chose to end the Explorer Planetary mission after the Saturn mission was finished and sent both Explorer 1 and Explorer 2 beyond our planetary group at a speed of 325 million miles each year. In January 1990, the new mission, formerly known as the Explorer Interstellar mission, began. Some of the most famous photographs in history portraying the Sun and the majority of the planets were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. They are regularly referred to as the Solar System Family Photo. There were 60 shots taken by Explorer 1, bringing the total number of photographs taken by the spacecraft to 670. In spite of the way that Mercury and Mars couldn't be seen in the photographs due to multiple factors, eventually, the rocket's cameras were stopped to conserve power and memory before its journey to interstellar space. NASA also operates the Voyager 10, Voyager 11, and New Horizons spacecraft. Before Explorer 1 passed by the Voyager 10 on February 17, 1998, the Voyager 10 was the farthest space apparatus. Explorer 1 continued its journey for a further 14 years before it finally arrived in the interstellar medium on August 25, 2012. With no other space tests in sight to find, NASA didn't publicly report the achievement until 2013. Let's go to November of 2018. Both space tests have officially left the nearby planet group when Explorer 2 crossed the heliopause and entered the interstellar medium. Explorer 1 is remembered to be 145 billion miles or 1550 light-years from Earth. It has continued to give us significant data that no other space test missions have had the option to disclose since it entered the unseen region past our solar system. The spacecraft has spent the greater part of its 45-year trip in space in great health. However, lately specialists have discovered a few odd peculiarities in its performance. Explorer 1 is currently sending baffling signs back to Earth, giving the feeling that it is uncertain of its location. There is, however, a frightening twist to the issue. Typically, researchers have pre-programmed Explorer to go into safe mode or sound an alarm in the event that it becomes lost in space. But so far, its receiving antenna, which sends information back to Earth, seems to be in good working order, although the information it has recently been communicating is dubious. The interstellar Voyager is working routinely, taking instructions from Earth and carrying them out, as well as gathering and sending scientific data. However, readouts from the spacecraft's communication and control systems don't exactly reflect what is happening inside. According to a NASA official statement, what exactly is happening on board? Each rocket that is going toward interstellar space, including the Explorer 1 and 2, has an exceptional 12-inch diameter gold-plated disc that is loaded with sound and video messages as a backup in case an extraterrestrial species finds the spacecraft. The disc contains 35 Earth sounds, 115 life photographs, 90 minutes of Western music, and good wishes from former U.S. President Jimmy Carter. Additionally, former UN Secretary-General Kurt Waldheim's message is also included. The items on the space DVD are kept in 55 different languages, so if it was taken over by aliens, they would likely be attempting to interpret the signals. Thoughts that the spaceship is currently under the course of extraterrestrials have been quickly invalidated by researchers. Explorer's capacity to work depends heavily on the demonstration attitude and orientation control instrument. For starters, it always keeps its antenna focused on Earth so that researchers can accurately receive information. Moreover, it controls how the spaceship is situated. Engineers watching out for the situation now feel that the spacecraft is functioning as it should, which simply adds to the mystery we currently face. Furthermore, none of the safety features designed to protect the spacecraft from danger have been activated by Susan D., mission director for Explorer 1. To a mystery like this is standard for the course right now in the Explorer mission. The spacecraft are both around 45 years old, which is much older than what was imagined in the mission plan. Sund also acknowledges that the spacecraft's engineering team will experience some significant challenges in solving the issue with Explorer 1 due to the distance between us and the space test. The difficulties are considerable, largely because the spacecraft is roughly 145 billion miles away from Earth. This enormous distance presents several complexities that the team must explore cautiously. A salvage operation is nearly impossible given the current technological and logistical limitations. Explorer 1 is a long way past the reach of any space apparatus or repair mission that we could realistically send. The spacecraft's incredible journey has taken it into the farthest regions of our solar system and beyond, into interstellar space, where it continues to travel further away from us every day. Messages received from Earth at the speed of light take nearly 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team requires a significant amount of time to be received by the spacecraft. This delay poses a major challenge for ongoing problem-solving and troubleshooting. Moreover, once Explorer 1 processes the command, any response or information it sends back to Earth will take an additional 21 hours to return. This implies that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it incredibly difficult to carry out timely solutions or iterative troubleshooting processes, which are often essential when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating different situations and possible outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Every instruction must be carefully designed to address the known issues without causing unforeseen problems, considering the extensive time it will take to confirm whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are transmitted to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, although state-of-the-art at the time, is now considered outdated by modern standards. The engineering team must work with equipment and systems that were designed and built during the 1970s, which adds another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant wear and tear on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains dedicated to solving the current issues. They are exploring various theories about what may be causing the anomalies and testing potential solutions through simulations on Earth. This careful, calculated approach is essential given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer 1's systems. Like many space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems or reconfigure existing components to bypass the problematic parts. NASA stated in a new statement that, until the cause of the issue is better understood, the team cannot predict how long the spacecraft will be able to gather and transmit scientific data. Nonetheless, Susan D. and the team are confident that the issue will be resolved, if it's something that can be fixed with the ACTX system, which controls the spacecraft's orientation and communication. The spacecraft's remarkable journey has taken it into the farthest regions of our solar system and beyond, into interstellar space, where it continues to travel further away from us every day.